Here's the thing most people missed. China was never really racing to land on the moon. It was quietly building the system behind the landing, and in 2024, the curtain finally lifted. On June 25th of that year, a Chinese spacecraft delivered 1,935 grams of soil and rock pulled from the far side of the moon, the first material ever returned from that hidden hemisphere. The samples came from the South Pole Aitken Basin, one of the oldest and deepest impact scars anywhere in the solar system. And then came the renderings detailed public plans for a permanent base near the lunar South Pole, a station meant to run for decades. Suddenly this stopped looking like exploration, it started looking like construction. Section 1. The long game. To understand why, you have to go back to the early 2000s, when Chinese planners laid out a lunar roadmap that stretched across decades. The goal was never one dramatic mission. It was to assemble, piece by piece, every capability needed to operate permanently beyond Earth. It started with orbiters mapping the surface, building topographic models, scouting the terrain engineers would need later. Then came the landings. In 2013, China became the first country since the 1970s to softly set a rover down on the moon. And in 2019, it did something many experts had called nearly impossible. It landed on the far side, where the body of the moon itself blocks all direct contact with Earth. China solved that by parking a relay satellite in just the right orbit, where it could see both Earth and the hidden hemisphere at once. Each mission taught the next one how to survive. It wasn't a sprint, it was a machine being built one bolt at a time. Section 2, but what the samples said. For half a century, we thought we already understood the moon. Apollo had walked its surface, hauled back hundreds of kilograms of rock, and an entire scientific story had been written from those samples. Then China landed on the far side, and that story started to crack. When scientists opened the new material, the rocks showed signs of volcanic activity far more recent than the models predicted. Some of that far side basalt dated to roughly 2.8 billion years old, meaning the moon stayed alive, geologically, much longer than anyone expected. Other studies hinted the moon's magnetic field may have surged back around the same time, and that the far side mantle is strangely dry compared to the near side. In other words, the moon isn't the simple dead rock we pictured. It's lopsided, complicated, and far more valuable. And that changed how these missions looked. They didn't look like science anymore, they looked like prospecting. Section 3. The darkness that matters. Because the most important place on the moon may be the one spot sunlight almost never reaches. The moon barely tilts on its axis, so near the poles the sun hits at an extreme sideways angle, and some crater walls are so deep the floor has never seen light at all. Not for a season, not for a century, in some places not for billions of years. These are the permanently shadowed regions, and inside them temperatures can crash below minus 170 degrees Celsius, colder than the daytime surface of Pluto. For decades, scientists suspected those frozen pits were hiding something extraordinary. Water. Over billions of years, comets and water-rich asteroids slammed into the moon. Most of that water was blasted away by sunlight or lost to space. But inside those dark craters, the cold became a natural deep freezer. Whatever drifted in almost never escaped. Section 4. Why water changes everything. And here's why a little frozen water flips the entire equation. The models vary, but they suggest the moon's poles could hold anywhere from hundreds of billions to potentially trillions of kilograms of ancient ice. Because water in space isn't just water. Split it apart and you get oxygen to breathe and hydrogen to burn. And hydrogen and oxygen together make one of the most powerful rocket fuels we've ever flown. Now think about what that does to the cost of everything. Launching from Earth is brutal because every single kilogram has to claw its way out of the strongest gravity we can launch from. But the moon's gravity is only about a sixth of ours. If you can make fuel on the surface, then ships bound for Mars or the asteroids don't have to carry it all from home. They top off at the moon. The moon stops being a destination. It becomes a gas station for the rest of the solar system. Section 5. The robot that jumps. But finding that ice is its own nightmare. Those craters are among the harshest places in the solar system. No light, no warmth, jagged ground untouched for eons, cold enough to kill ordinary electronics. A normal solar-powered rover wouldn't last, so China designed something stranger. Its next South Pole mission isn't one spacecraft. It's a whole coordinated system, an orbiter overhead, a lander, a rover on the lit surface, and something no nation has ever flown on another world. A hopping probe. Instead of rolling on wheels, this little robot is built to leap directly into the permanently shadowed craters wheels can't enter, carrying an instrument designed to sniff out usable water ice. It's meant to jump in stages, descending into pits where the ground hasn't seen sunlight in over 1 billion years. Think about that. Places frozen and untouched since before complex life existed on Earth, and China built a machine to jump into them. Section 6. Baking bricks from moon dust. Finding water is only step one. The harder problem is building, because shipping construction material across nearly 400,000 kilometers of space is almost absurdly expensive. So China wants to skip the shipping entirely and manufacture on-site. The plan centers on using local lunar soil itself, a solar furnace that focuses sunlight to heat regolith to around 1,400 degrees, hot enough to melt it into solid material. Put simply, they want to bake bricks out of moon dust, then 3D print structures layer by layer. Landing pads to tame the dust storms kicked up on touchdown, walls to shield crews from radiation, roads and eventually habitats printed straight onto the surface, and the testing is already underway. Experimental lunar bricks have been mounted outside a space station to see if they can survive raw radiation, vacuum, and brutal temperature swings. The moon is no longer a place humans briefly visit. It's becoming a place machines start building before humans even arrive. Section 7. The network. And once you line it all up, the mapping, the far side landings, the water hunt, the brick experiments, the relay satellites, the pattern is impossible to miss. None of it was isolated. Every mission was a piece of one much larger thing, an actual lunar infrastructure network. China calls it the International Lunar Research Station, and for years people treated it like science fiction. Not anymore. The plans now openly describe a station near the South Pole with surface facilities, orbital relays, navigation, transport and power. Even an agreement to study putting a nuclear reactor on the moon to carry the base through the 2-week lunar night. A basic version is targeted for the mid-2030s, with a far larger network stretching across the moon by around 2050. So when people ask what China found on the far side of the moon, the honest answer is bigger than a rock. They found that the moon was never the dead, finished world we filed away in textbooks. It's older, stranger, wetter, and more useful than we let ourselves believe. And they're not visiting it, they're moving in. If this rewired how you see that grey dot in the night sky, give this video a like and subscribe so you don't miss what comes next. And tell me down in the comments, is a permanent moon base humanity's greatest leap? Or are we just planting flags on a new frontier? I want to hear where you land.